Hey guys, this is Gavin once again, and in this video we'll be looking at the second method on how to solve simultaneous equations or simultaneous equations. So how do you solve? As I mentioned before, there are a few ways to solve these simultaneous equations. However, in this video we'll be looking at solving simultaneous equation using substitution method or using substitution method. So in this method, the idea of this method is basically try to isolate a polynomial. Once you have isolated a polynomial in one of the equations, the next step is to substitute its value or its expression into the other equation, right? And then you end up with one polynomial in one equation, and which is easy to solve as it's a linear equation, right? So let's do that and see how it goes. Now in this example, we have got y equals 2x plus 3, right? So that's our first equation, and the second equation is 2x plus 4y equals 5, right? That's our second equation. Now, as I mentioned, in this method, we are trying to isolate one of the polynomial and substitute the equivalent or its expression in the other equation, right? So here we have got y is already isolated, right? Y is already isolated, so y equals 2x plus that. Now, the next step is to take the expression of y and substitute into the second equation, right? So what you do is substitute equation 1 into equation 2, and what you then have, once you do that, what you then have is you have 2x plus 4y is equal to 2x plus, so instead of y, I'm putting this value. Instead of y, I'm putting this value, right? 2x plus 3 times 2x plus 3 is equal to 5. Now let's solve this. This is a linear equation, right? Let's solve this. So this is equivalent to 2x plus 4 times 2x is 8x. Plus 4 times 3 is 12 is equal to 5, right? Now 2x plus 8x is 10x plus 12 equals 5, right? And then my next line, which should then be subtract 12 on both sides, right? Subtract 12 on both sides, you end up with 10x here is equal to subtract 12 on both sides here, minus 12, we get a negative 7, right? And therefore our x value will be divided by 10 on both sides, will be negative 10, 7 on 10, right? So let's just double check if we have done the right things, right? So we go to x plus 4y, and then we substitute the value of y to x plus 3 equals that, and we expanded this to x plus 8x plus 12 equals 5. Then 2 plus 8, 10x plus 12 equals 5. 10, we subtract 12 on both sides, so we isolate the x. Now when we do that, we get negative 7 on the right hand side and 10x, so x equals that value. Now once you have got this value, here, you then substitute this value into the first equation, right? You don't use the second equation, just use the first equation because you have already used this. So what you then have sub x equals negative 7 on 10 into equation 1, right? Then when you do that, is you have y equals to 2, right? So it's 2 times negative 7 on 10 plus 3, right? Now next line, you have y equals to, when you expand that, you get 14. So you could simplify this. Let's just simplify this, right? 1 divided by 2 both sides, so this is 5, right? You then have negative 7 on 5 plus 3. Now when you add the fractions, you find common denominator, which is 5 minus 7, and then here is like over 1, but then when it times it by 5 it will be 15, right? Plus 15, so the value here is 15 minus 7 is 8 on 5, right? So y, so the value of y is 8 on 7, right? So 8 on 7 is a positive value. Now, so those are our two values, right? So you could just do therefore x equals to negative 7 on 10 and y equals 8 on 5. And you could double check this. For instance, 8 on 5 right here, so is equal to as we saw 2 times 7 on 10, right? 14 on 5, which is just 7 on 5, right? 7 on 5 plus 3, as we have go, just 8 on that, right? And you could do the same thing here, because if you take this two value here, it will be 7 on 5 minus 7 on 5 plus 8, 32 on 5. When you add those two values, it should give you 5, right? Thank you so much, guys. And this is one example. Oh no, I've got another example for you, right? I've prepared another example. Let's look at this one. So in this example here, remember the previous example y was isolated already, but in this example we have got x isolated already. So it's really about isolating one out of the polynomial and then substitute its equivalent expression in the other equation, right? So let's do it now. What we then do, substitute equation 1, 1 into 2, 1 into 2, 1 into 2, right? When you do that, you then have 4 times 2y minus 11 plus y equals negative 8, right? And then on my next line, I'm gonna expand this to be 8y minus 44, right? Plus y equals negative 8, and then here 8 plus 1 is just 9y minus 44 equals negative 8. 9y, then subtract our 44 on both sides. Here you have to add the 44 on both sides, you get 0 here, but then when you add the 44 on this side, you get 36, right? So you get 36 on that side, 36, and then here you use positive 36, right? Because you have 44, positive 44 minus this value, right? So it should give you positive 36. Y therefore y equals to 4, right? Because you're dividing by 9 on both sides. Once you've got this value of y, then you can substitute y equals 4 into, because we have to substitute back in equation 1 into equation 1, right? So you have x equal 2 times 4 minus 11, right? And then you have 8 minus 11, therefore our x will be negative 3, negative 3. So these are two values for our equation. However, what you could you have to write as a solution. So x equals to negative 3 and y equals to 4. So these are our two values, right, for x and y, and you could substitute in this value, right? So for instance, here if x equals if you're solving for x, just 2 times 8, 2 times 4 is 8, sorry, minus that, you get negative 3. But if you substitute here as the value of y, right, we just put in the value of x, negative 3 will be negative 12 plus 4, negative 8, right, which is correct. Alright guys, thank you so much for watching our video. Like, share, comment, and remember to subscribe to our channel if you haven't done so. I will see you in the next video where we'll be looking, I believe we'll be looking at another method on how you could solve simultaneous equations. See you soon.